Hey, welcome back to my channel, Learn CC Chemistry and Physics. Today we are looking on the chemistry topic, writing ionic equation. Now, the first thing we need to do, I'm assuming that everybody is able to write balanced chemical equation. So we start with a balanced chemical equation with the correct state symbol, right? Then we are going to assess the nature of the compound. So we do this in order. Then we're going to assess the nature of the compound. Is the compound metallic? Metallic substance are just uncombined metals. Then we assess if the substances are covalent. So when we talk about a substance being covalent, the covalent substance that we generally are going to be using are going to be our water, our hydrogen, chlorine, even if it have aqueous. So chlorine in whichever state is covalent. Iodine is covalent. We have carbon dioxide, those are covalent substances. Oxygen gas, those are covalent substances, right? So covalent substances has metal and non-metal. And then of course we have ionic substances. Ionic compound comprises of a metal and a non-metal, or a metal and a polyatomic ion. And the state symbol is solid, it means we have an ionic solid. And if we use aqueous, it means we have aqueous ionic compound. So that's how we assess the nature of the compound. Then we are going to rewrite the equation, breaking up only the ionic aqueous ions into aqueous compound into ions. You may go ahead and watch that video. I'm gonna put the link up top, where I spend 6 minutes explaining how we break up aqueous ionic compound into ions. Then we are going to delete spectator ions. After we delete spectator ions, a spectator ions is an ion that is the same on both sides of the equation. Then we're going to write back what is left. And then if we have the same number in front of all the compounds, we are going to cancel them out. All right, so we're going to do this. So I'm giving you a balanced chemical equation. And then from the balanced chemical equation, we are going to assign these steps so we can go ahead and write the ionic compound. Here we go. So we have the balanced chemical equation. Then I'm assessing the nature of the compound. So this is an acid. All acids are aqueous ionic compound. So I'll go write AQ. This is sodium. Sodium is a metal. So I go ahead and write M, indicating it's metallic, right? And then I am looking at this compound, it's sodium nitrate. It is ionic. And I look at the state symbol, it's ionic aqueous. And here I have H2. H2 is covalent. So I have assessed the nature of the compound. Then I'm going to rewrite the equation, breaking up only the ionic aqueous compound into ions. So therefore, I'm going to be breaking up these two compounds into ions. Now again, rewatch the video of how I did that. So this compound has 2 nitric acid, means I have 2 H plus ions aqueous, and I will have 2 times 1 nitrate, 2 nitrate ions aqueous, and I put the state symbol there. No, I cannot break up the metallic compounds. I write it back as is. So it's 2Na solid. Then I have sodium nitrate, comprises of 2 ions, the sodium ion and the nitrate ion. The 2 there means it's 2 sodium ions. And the 2 times 1 nitrate means I have 2 nitrate ions, aqueous. And the H2 gas means it's covalent. I cannot break up that compound into ions. So step number 4 says delete the spectator ions. This is ions that are the same on both sides of the equation. So I'm seeing 2 ions on the left, 2H plus ion. I look on the right, I'm not seeing that. Then I see 2 nitrate ion. I'm seeing that on the right. So I go ahead and I delete that. So I write back what is left. with the correct state symbol and charges. Then the last rule say if you have the same number in front of all the compound or ions, cancel them out. So I'm seeing 2H plus ion, 2 sodium ion, and I'm not seeing 2 in front of hydrogen, so I cannot cancel it. So my ionic equation is this: 2H plus ion aqueous plus 2 sodium metal produces 2 sodium ion plus hydrogen gas. So I'll give you a minute to take off that. So we have another balanced chemical equation that we're going to go ahead and convert to ionic equation. So here we have hydrochloric acid reacting with magnesium to form magnesium chloride and hydrogen gas. So it's 2HCl, 2 moles of hydrochloric acid reacts with 1 mole of magnesium to form 1 mole of magnesium chloride and hydrogen gas. So it says assess the nature of the compound. Is the compound metallic, covalent, ionic solid, or ionic aqueous? So here we have an acid. Acids are ionic aqueous. Here we have a metal. Metal is metallic. Here we have magnesium chloride, which is ionic aqueous. And we have hydrogen gas, which is covalent. Then it says, rewrite the equation, breaking up only the aqueous ionic compound into ions. So I'm going to be breaking up these 2 compounds into ions and write back everything as is. So 2HCl means I have 2 hydrogen ion, 2 chloride ion, magnesium, Mg solid, I write it back as is. Magnesium chloride is Mg 2 plus ion, has 1 magnesium ion. And the Cl2 means I have 2 chlorine. The 2 is going to go in front of the chlorine. And I have hydrogen gas. So now I'm going to go ahead and delete my spectator ions with, so it says delete the spectator ion, that is any ions that are the same on both sides of the equation. I'm seeing 2H plus aqueous. I look on the right, I'm not seeing that. 2Cl minus aqueous, I see that on the right, so I go ahead and delete. Then it says write back what's left, so what would be left would be my 2H plus ion, my magnesium solid, then my magnesium ion, and I write back my state symbol as well, and my H2 gas. So this is the ionic equation. So you have a reaction where I'm reacting acid with metal carbonate to form salt and water. So it's sulfuric acid reacting with copper oxide forms copper sulfate and water. So I have the balance equation already. This equation is already balanced. And then it says I must assess the nature of the compound. Acids again are ionic aqueous. Here I have copper oxide, that is an ionic compound, but metal oxides are solid, so it's ionic solid. Here I have copper sulfate, which is ionic aqueous, and then I have water, which is a covalent substance. I am going to break up aqueous ionic compound into ions. So here I have H2SO4. That's what I'm breaking up on copper sulfate. So when I break up H2SO4 into ions, in this compound I have 2 hydrogen ions. The 2 goes in front. So it's 2H plus aqueous. And then I have a sulfate ion. The formula of the sulfate ion is SO4 2 minus aqueous. And then it forms copper oxide. And then I have I don't break up this compound because although it's ionic solid. I'm gonna break up copper sulfate. This comprises of 1 copper ion, 1 copper 2 plus ion, 1 SO4 2 minus ion, Water is covalent, so I rewrite water as is with its state symbol. Now we're going to go ahead and delete any ions that are the same on both sides of the equation. I'm seeing 2H plus aqueous. I look to the right. I'm not seeing 2H plus aqueous. I look on the next ion, which is SO4 2 minus. When I look on the right-hand side, I'm seeing SO4 2 minus, so I delete that. Simple means it is a ionic, it is a spectator ion, so I go ahead and delete that. Then I write back what is left. Sorry, this is supposed to be an arrow. So I write back what's left. And I get water, liquid. So that's the ionic equation right there. In this reaction, I'm reacting potassium hydroxide, which is an alkali, with the acid. So it's an acid-alkaline reaction. It forms salt and water. So I have 1 mole of phosphoric acid reacting with 3 moles of potassium hydroxide aqueous to form 1 mole of potassium phosphate and 3 moles of water. So I'm going to assess the nature of the compound. This compound is an acid, so it's ionic aqueous. Sodium hydroxide is ionic. The state symbol is aqueous because all sodium salts are aqueous. This is the sodium salt, so it's aqueous, and I'm seeing water there, which is covalent. I'm going to break up all the ionic aqueous components into ions. So H3PO4 has 3 hydrogen ions, so the 3 goes in front. Phosphate ion is PO4, 3 minus aqueous. This 3 here means I have 3 times the 1 sodium. The 3 goes in front. So it's 3K plus. 3 multiplied by the 1 hydroxide means I have 3 hydroxide ions. And 3 here means I have 3 sodium ion. The 3 goes in front of the sodium ion. I have 1 phosphate ion. And I have 3 water that I will write back because water is covalent. Then I'm going to go ahead and delete my spectator ions. 3H plus, I'm not seeing 3H plus on the right. PO4 3 minus, I look on the right. I am seeing that, so I delete that. 3 sodium ion, I am seeing that on the right, so I delete that. So what I'm left with is 3H plus ions, 3 hydroxide ions, and 3 water is formed. Now, when I look on rule number 6, it says, if the same number is in front of all the compound or ions, cancel them out. Now, 3 is in front of all of them, so I'm going to cancel it out. So what I'm left with is H plus, OH minus, and water, liquid. All right, so you have an acid reacting with the hydrogen carbonate and it forms salt, water, and carbon dioxide. So we have sulfuric acid, 1 mole of sulfuric acid reacting with 2 moles of lithium hydrogen carbonate to form 1 mole of lithium sulfate, 2 moles of water, 2 moles of carbon dioxide. Assess the nature of the compound: ionic aqueous, ionic aqueous, ionic aqueous, covalent, covalent. Break up ionic aqueous into ions. So these are the 3 I'm going to be breaking up. The 2 here means I have 2H plus, 1 sulfate ion. Remember, lithium hydrogen carbonate comprises of only 2 ions. The lithium ion, 2 times 1 gives me 2 lithium ion. Hydrogen carbonate ion, which is HCO3. I have 1 there, but 2 times 1 gives me 2 hydrogen carbonate ion. And then I have 2 here, so it's 2 lithium ion. one SO4 2 minus ion, and then I have 2 water plus CO2 CO2 gas. Cannot break up water and carbon dioxide because those compounds are not aqueous ionic, so I rewrite them back. Then I delete the spectator ions that are the same on both sides of the equation. So I'm seeing 2H plus. On the left, I look to the right, I'm not seeing that. Then I see SO4 2 minus on both sides of the equation, so I delete that. 2Li plus, I look to the right, I see 2Li plus, so I delete that. So I have 2H plus aqueous plus 2HCO3 minus aqueous, and I form 2 water, liquid, and 2 carbon dioxide gas. So 2 is in front of everything. I'll go ahead and cancel out that. So what I have is H plus aqueous, HCO3 minus aqueous, plus H2 liquid plus CO2 gas. So that's my Ionic equation. Here we're reacting an acid and a metal carbonate. No, this metal carbonate is insoluble, so we have zinc, we have sulfuric acid and zinc carbonate. 1 mole of sulfuric acid reacts with 1 mole of zinc carbonate to form 1 mole of zinc sulfate, water, and carbon dioxide. So this comprises of 2H plus ion. When we assess the nature, this is ionic aqueous, ionic solid, ionic aqueous, and then these are covalent substances. So we're going to break up these compounds only into ions. So that gives me SO4 2 minus aqueous. I write back the zinc carbonate as is because I'm not breaking that up. And then zinc ion plus SO4 2 minus ion gives me water and carbon dioxide. So I'm deleting the spectator ions, which is the SO4. So it's 2H plus aqueous, right? But the zinc carbonate, solid, and it gives me zinc ions plus water, liquid, and CO2 gas. So that's my balance equation. That's my balance ionic equation. So here we're doing a displacement reaction of elements in group 7. So we have 2 potassium iodide reacts with 2 moles of potassium iodide, reacts with 1 mole of chlorine to form 2 moles of potassium iodide and 1 mole of iodine. So we assess the nature of the compound. Potassium iodide is ionic aqueous. Chlorine, Cl2, is non-metal only, so that's covalent. So even though it have the aqueous sign, it is still covalent. Then we have 2 potassium chloride, that is aqueous ionic, and we have I2, which is covalent. So we break up these 2 compounds into ions. So we will have 2 K plus ions, 2 I minus ions. We're going to write back the Cl2 aqueous and then break it up into 2 K plus aqueous plus 2 Cl minus ion, and write back the I2 aqueous because it's covalent, and then we delete the spectator ions, which are going to be the sodium ion, the potassium ion, sorry. So it's 2I minus aqueous plus Cl2 aqueous produces 2Cl minus aqueous and I2 aqueous. All right, so we're reacting magnesium with copper sulfate. So magnesium is being replaced. Magnesium is replacing the copper here. So for magnesium sulfate and copper. So we're going to write ionic equation for this reaction. This compound is metallic. Copper sulfate is aqueous ionic. Magnesium sulfate is aqueous ionic. Copper is metallic. So we have Mg solid breaks down to give us copper 2 plus aqueous, SO4 2 minus aqueous produces Mg 2 plus SO4 2 minus aqueous and copper solid. So we're going to delete the spectator ions, which in this case is sulfate. So Mg solid plus copper 2 plus aqueous produces Mg 2 plus aqueous plus copper solid. This gives us the ionic equation. So that's it for ionic equation. Leave a comment. Let me know how you like this video. If the concept is clear to you. Have a good day.